Question 1. Write 6,819 to the nearest thousand. Well, we've got our units here, then we've got our tens, then here's the hundreds, and this one is the thousands. So if we want this to the nearest thousand, well, it seems to be 6,000, doesn't it? But don't forget, when we round, we look at this number after the number we want to round it to. And if this number here is a 9, an 8, a 7, a 6 or a 5, then it increases this number by 1. But if this number is a 4, a 3, a 2, a 1 or a 0, it has no change. So the answer would not be 6,000 to the nearest 1,000, it would be 7,000 to the nearest 1,000. Question 2. Write these temperatures in order. Start with the lowest temperature. Well, if we draw a number line, say going from -10 all the way through to say 10, then 0 is going to be here. So we can put 10 on the number line, there it is, 10 degrees centigrade. And then if we think about it, halfway between 0 and 10 would be 5 degrees centigrade, and that's not shown on here, but here there's -5, so -5 will be halfway between 0 and -10. So our -5 degrees centigrade is going to be there. Now, if you think about it, here's 3 degrees. Now, if this is 5, then by estimation, that's about 4, 3, and so on. So there's 3 degrees there. And then 7 degrees, well, that'll be closer to 10, so that's around here somewhere. And that just leaves -2. Well, if here is 0, then if we go back 1, that'll be -1, -2 will be around here. So start with the lowest temperature and we put them in order. So there we go, -5, -2, 3, 7 and 10. So that's one way that a simple number line can help you. You may not need it, you may be able to do it without. Question 3. Write 0.075 as a fraction. Give your fraction in its simplest form. Well, I use an FX 85 GT Plus. They're quite a cheap calculator from Casio, and funnily enough, when I put 0.075 in and press equals, I get 3/40, which would be the answer. Now, for 2 marks, I'm just not quite convinced that just putting it into your calculator and pressing equals would give you the 2 marks. It might give you 1 mark. So what I would do is, I would take the fraction, the decimal rather, and I would think to myself, well, 75 whole ones, that's just 75. 75 tenths, well, that would be 7.5. 75 hundredths, well, that would be 0.75, and so 75 thousandths would be the fraction equivalent of 0.075. So if I take the 75 thousandths, this is where you can use your calculator. You can say, well, how many 5s go into 75? Well, you can divide 75 by 5 on your calculator and you'll get 15. And then you can do the same to the bottom and you'll get 5 lots of 200. These would cancel because, don't forget, 5 divided by 5 is just 1. So that's just the same as 1, 5/5. And then you can say to yourself, does 15 and 200 have anything in common? Yes, they do. You can say that the 15 would be 3 times 5, and the 200 would be, well, how many 5s in 200 do you think? Well, it's going to be 40 times 5. And again, 5/5 cancels and you're left with 3/4. So you can use the calculator straight away, but I doubt if it would get you the 2 marks. I think you'd have to show a little bit more working out, even if you just said, okay, 75 thousandths, and then maybe what you could do is divide both sides by 25 top and bottom, and you'd have 3 times 25 here, and then you'd have 40 times 25 here, and just a simple cancellation would probably be enough. Question 4. Find the value of 5 to the power 4. Well, 5 to the power 4 means that you'd have 5 times by itself again, times by itself again. Now, this is the same as 5 to the 1 times 5 to the 1 times 5 to the 1 times 5 to the 1. So how many powers of 5 do we have? Well, 1, 2, 3, 4. So all we have to do on our calculator is either 5 times 5 times 5 times 5, which would be 25 times 25, which is 625, or you can just type in 5 to the power, and the button I use for the power looks like this, and that would give you the answer 625 straight away. But some people complain saying, well, you've got a calculator, just use it. I suggest that you kind of understand what's going on behind the scenes. Don't just type something into a calculator if you're not quite sure what it means, okay? Because you'll not learn much from that. Question 5. It says here that there were 720,000 babies born last year, and it says 1 in 3 of them are expected to live to 100 years old. Well, 1 in 3 is the same as 1/3, so we want 1/3 of those babies would be expected to live to 100 years old. And how would you do that on the calculator? Well, there's a couple of ways. You can either do 1 times 720,000 and then press divide 3, and that will give you, I believe, 240,000. Or you can just simply do 720,000 divided by 3. And the reason for that is that because you've got 1 times 720,000, that's just the same as 720,000. And really, this is like having a fraction 720,000 whole ones. So this 3 and the 1 here, when they're multiplied, just give a 3. So this fraction is exactly the same as writing all of that. So you can just simply put this in your calculator and that would be the answer. Question 6. Here is part of a train timetable from Swindon to London. The first part says, how long should the 6:58 train from Swindon take to get to London? Well, this is the train in question, and this is where it gets to London here. So we want to go from 06:58 right through to 08:02. So to get to 7 o'clock, well, that's 2 minutes. And then to get to 8, that's another hour, so that's another 60 minutes. So I can make this in minutes here. And then we've got another 2 to get to 08:02. So if we want it in hours and minutes, then we can say there's 1 hour here and then 2 4 minutes. So that would be my answer. Claire says all these trains take more than 1 hour to get from Swindon to London. Is Claire correct? Well, let's have a look at this one first. So from here to here, if we just added 1 hour, we'd get from 06:10 to 07:10. So this one is more than 1 hour. From here to here, well, that's more than 1 hour. This one is more than an hour as well. This one we've already done, we know that to be true. This one here is more than an hour. But look at this one. From 07:17 to 08:14, well, that's less than an hour. So we're 3 minutes short of an hour, so that's 57 minutes there. And this one here, well, that's more than an hour. So we can say here that the 0717 arrives in less than 1 hour, so Claire is wrong. Okay, so that wasn't too bad, that question. Question 7. Tracy buys the following items and shares the total cost equally between 5 people. So it says, how much does each person pay? So you can use your calculator here, but to develop numeracy skills, of course, I'm going to look at it without as well at the same time. So we'll have 2 lots of the coffees at £1.10, so that'll be £2.20. 3 of the teas at 95, so that will be the same as £3 with 15p taken off, and that's going to be £2.85. And then 5 sandwiches at £2.15. Well, there'll be 5 lots of the 2, that'll be the £10, and then 5 lots of the 15, that'll be 75. So we've got £10.75 there. So if we add up all these amounts here, then we've got £10.75, £2.85 and £2.20. So we're going to have 15, 17, 18, £15.80p. And what we're going to do then is share that cost equally between 5 people. So you've probably done that on your calculator, but if you want to practice your division skills as well while you're revising, then we're going to have 1 remainder 3. So we're going to have £3.16p. That's what each person would pay. So not too bad a question, especially with a calculator. That's absolutely fine. Question 8. Rachel carried out a survey of 10 people to find out the type of fruit they like best. The table gives the information about her results, and it says, which type of fruit is the mode? Well, mode, or the word modal, means the most popular, the one that happens the most. So in this case it was banana. And in Rachel's survey it says 2 out of 10 people liked apples best. So 2 out of 10 as a percentage, well, that'll be 20 out of 100, wouldn't it? Because if you take 2 out of 10 and you times top and bottom of this fraction by 10, then you make the numerator 20, the denominator 100, and anything out of 100 is automatically a per, which means divide, cent 100 of 100. So it's 20 per 100, so it's 20%. On the calculator, of course, most calculators you can just do 2 divided by 10 and times by 100, and that will give you the percentage 20%. So if you do 2 divided by 10, on some calculators you'll see 0.2, and all you have to do is just realise that you can go between this as the fraction, this one as the decimal, and then this one here would be the percentage. Okay, so fractions, decimals, percentages, you've got to be really good at going between each and every one of them. Now, Pete also carried out a survey to find out the type of fruit people like best. He asked 30 people which type of fruit they liked and they like best, and he drew this pie chart for his results. It's a bit fiddly this, but it says a smaller proportion of people like bananas best in Pete's survey than in Rachel's. Right, so let's look at Rachel's first. Now, out of the 10 people that she asked, 5 out of the 10, which is a half of them, or 50% of hers that were surveyed preferred banana. But out of these 30, you can see here that banana does not have half, because if it was half, it would be this much. Okay? And you can see clearly from the pie chart shown that it's not the same proportion, it's less. So a smaller proportion of people like bananas best in Pete's survey. Yep, that's true, and you can explain how that's done in words yourself. I've just shown you in terms of the diagram. Okay, so you've just got to be able to put that in words and just write in a very few simple sentences, and you'll get the marks for that. Okay, so that's that question done. Question 9. It says the smallest angle of a triangle is 25 degrees. The triangle is enlarged by a scale factor 3. So if we had a triangle where its smallest angle was 25, let's just say there it is, that's 25 degrees there. And it says the triangle is enlarged by a scale factor 3. So to enlarge a triangle means they're going to be similar. So if you made it 3 times bigger, you'd have something like this. Okay. Now think about it. The angle here couldn't actually get bigger, because if it did and became 75 like Ben thought, then 75 would be, well, it wouldn't be the same triangle, would it? You'd have an angle something like this for the angle here. And if you enlarge that by a factor of 3, you would not get similar triangles. When you enlarge something, this triangle here, the smaller one, which I can draw separate, okay, has got to be similar to this large enlarged triangle here, the red one. Okay, and the nice thing about that is that this angle here, and I'll draw another colour here, that this angle here corresponds to this angle here, this one here corresponds to this one here, and this one corresponds to this one. Okay, so angles do not enlarge by the same scale factor, and you can write something like this as your answer. So you can write Ben is wrong because the triangles will remain similar, the angles must remain the same. So I'm sure there's other answers that people could write as well, i.e. maybe something simple like under enlargement the angles are preserved, but a diagram with a bit of an explanation. I know it's only 1 mark, in fact I think that it's probably worth 2, but okay, 1 is what it says on this paper. Let's move on. Question 10. It says Carol ran a race and the graph shows her speed in meters per second, t seconds after the start of the race. And the first part of the question is write down Carol's speed 3 seconds after the start of the race. Well, let's go to 3 here. In the exam you would draw a dotted line, read across, and then look very carefully at the scale. There would be 7, so it would be 6.2, 6.4, I would go with 6.6 meters per second. Now it says write down Carol's greatest speed. Well, we can see here that the greatest speed would be here, and so we read across, and we can see here is 9, so we'd write 9.8 meters per second. The next part of the question says there were 2 times when Carol's speed was 9 meters a second. Write down these 2 times. Well, if we just draw a dotted line at 9 meters per second, then we can see it hits the graph here at this time, which is quite clearly 5 seconds, and then it also hits the graph here, and if you read down you can see this is and 9 seconds. So 5 and 9 would be the answer. Question 11. The first 3 terms of a number pattern are 1, 2, 4. Hester says the first 5 terms of this number pattern are 1, 2, 4, 8, 16. Write down the rule Hester could have used to get the 4th and 5th terms. Well, to get this 4th term here, and then the 5th term, you could write something like, you could have doubled the previous term, or times the previous term by 2. Write down the 6th term. So if this is the first term, 2nd, 3rd, 4th, 5th, well the 6th one will be double 16, i.e. double the previous one, and that will be 32. Jack uses a different rule. He says the first 6 terms of the pattern are 1, 2, 4, 7, 11, 16. Write down the 7th and 8th terms. So we've got 1, 2, 3, 4, 5, 6, and we want this one and this one. So one thing I've noticed here is it goes up by 1, then 2, then 3, then 4, then 5. So the next one will go up by 6, and 16 and 6 is 22, and the next one up by 7, and 22 and 7 is 29. So I would say 22 and 29. Question 12. Martin has 8 pints of soup in a pan. He also has 24 soup bowls, and he intends to put 0.3 pints of soup into each bowl. So if he has 24 bowls and 0.3 pints in each of them, then we can do that on the calculator, and what you would get is 7.2. Now what would that mean? Well, if these are the bowls here, and this is how much of a pint that you're putting in each bowl, then this would stand for 7.2 pints of soup used so far. So if you know that there are 8 pints to begin with in the pan, and 7.2 pints were poured away, then on your calculator you could do 8 minus 7.2, and you'd get 0.8 pints. You could also do a subtraction sum like this. Okay, however you do your subtraction, I think most people probably do it this way and get the answer that way. Okay, so that's question 12, and that's not too bad. Question 13. Abby invests £500 for 4 years in a bank account. The account pays simple interest. Now, first of all, simple interest is very rarely paid in bank accounts. It's usually compound. The difference between compound and simple, well, compound means you have some money and then it gains interest over that first year, and then you end up with more in the account on the first year, and then in the second year you end up having interest charged on the money you've accrued over the first year, so it compounds, it gets more and more and more. What happens with simple interest is you just get the 2.3% per year, and then you just times that by 4 for how many years. So you end up getting less. So we can work it out here. So if we want to do 2.3% of 500, well, with your calculator, you can do 2.3 divided by 100 times, which is of 500. So let's have a look at what that is. So we've got 2.3 divided by 100 times 500. And that gives me £11.50. Now all I have to do then is just multiply that by 4, because that's how much I would get each time. So if I now times that by 4, you can do all this on your calculator, I end up getting £46. So that's the simple interest way. So if you want to go to the next question, that's fine. I'm going to do compound now. So the difference between that is that if you take the £500 and then you do exactly the same, you times it by 2.3 over 100, you'll end up with the £11.50, just like we had before. But what happens with compound is, so that's year 1. For year 2, you end up adding this £11.50 to the 500 that you started with, and you'll have £511.50, and then you just apply the interest rate again, so times 2.3 over 100, which is 2.3% of it, and I'll do that on the calculator. So you'll have £511.50 times 2.3 divided by 100, and that works out to be 11.7645, which you don't need to round, and bank accounts would not round that until the very end of the year. So it's to the nearest penny about £11.76. So can you see that's 26p more than what you'd have in the first year. So simple interest just does the £11.50, the £11.50, £11.50, £11.50 four times, whereas compound, it grows. So we'll do one more. We'll add this now to the £511.50 that we started with. So £511.50 plus the new interest, and I'll do that to all the 4 decimal places, 11.7645, and that would be 523.2645, times that by 2.3 over 100, so times by 2.3 divided by 100, and we end up getting £12 and 4p, and that's to the nearest penny now. So you can see that by the end of the third year, the interest that you would get on the amount is growing, okay? And that's how compound interest works. So that's that question. So simple interest, quite an old term and not very much used at all in banking nowadays. Question 14. The graph shows the cost of using a mobile phone for 1 month for different numbers of minutes of calls made. It says the cost includes a fixed rental charge of £20 and a charge for each minute of calls made. It says work out the charge for each minute of calls made. Well, I think this is quite a tough question, and I think a lot of you would find this quite tough. Now, if you use no minutes, then you pay the £20 because that's a fixed rental charge. If you used 100 minutes, then you would end up paying up to here. Now, how much would that be? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces for £10, so each space is £1. So for 100 minutes, that's £3, which is 300 pence. So it looks as though if we divide both sides by 100 here, we're going to get 1 minute is 3 pence. Now the nice thing about this graph is that it's a straight line, so no matter what we do, it's always going to be the same. So if we looked at this one, say 300 minutes, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 300 minutes would be £9 or 900 pence. And can you see, if we divide both sides by 300 there, we're going to get exactly the same. 1 minute is 3 pence. So the fact that it's nice and linear means that no matter where we started from, and I just chose an easy one here for the 100 minutes, we can always work out then the cost, the charge for each minute of calls made. So 3 pence per minute. So not too bad if you just understand how straight lines can help you. Question 15. Here is a list of ingredients for making chocolate mousse for 2 people. Don't forget that's for 2 people. It says Ellie has 250 grams of sugar and 550 grams of dark chocolate. She assumes that she has plenty of lemon juice and plenty of eggs. What is the greatest number of people Ellie can make chocolate mousse for? Well, it really depends then on the sugar and the dark chocolate not running out. So if we look at this 110 here for the dark chocolate, that will give us a really good clue, because the most we could times that by is 5, isn't it? And that would use up all the dark chocolate. That would use up 550 grams. So if we times all the other ingredients by 5, that would be 40 times 5. That would give 200 grams. You can use your calculator for that if you need to. 2 times the 5 would be 10 eggs. And a quarter times 5, that'll be 5 quarters or 1.25 teaspoons. Okay? And we're assuming that she's got enough of that anyway. However, if she wanted to do more, i.e. multiply this up by, say, another person, well, she'd be in trouble, because timesing this by 5, i.e. to make enough for 10 people, she's right at her limit on dark chocolate. Any more and she'd be not having enough dark chocolate left. My explanation would be 10 people is the maximum, because then all the dark chocolate is used, and that would be my explanation. Right, let's see if there's any more to this question. It says here, Ellie only has 6 eggs. What effect would this have on the greatest number of people Ellie can make chocolate mousse for? Well, she had 2 eggs to begin with, and 2 eggs made enough for 2 people. So this is not too bad, because that would mean that if she had 3 eggs, that would be 3 people, 4 eggs, 4 people, 5 eggs, 5 people. So 6 eggs would be very simple, and we can write our explanation here, and that is 6 eggs would make mousse for 6 people. Okay, so, and that would be our maximum. Okay, so not too bad a question there. Question 16. A sprinter runs 200 metres in 25 seconds. Work out the average speed of the sprinter, and that's in metres per second. So if we've got 200 metres in 25 seconds, if we divide top and bottom by 25, which you can do on your calculator, then you'll have 200 divided by 25 metres per 1 second. Okay, so you don't write the 1 second here, so your dimensions is metres per second, which is what we've got here. Look, metres per second, and the answer is 200 divided by 25, which you can use your calculator for, but you might be able to see that it's 8 metres per second. Question 17. Part A says simplify, and we have 7x and minus 3x. So in terms of the x's, we have 7x minus 3x, which is just 4x. So we can get rid of those. And then how many y's do we have? Well, we have 2y plus another 4y. So that gives us 6y. So we can just write 4x plus 6y. Part B, it says factorise. So what that means is, if we take 10x minus 15, if we break it down into some factors, say if we factor 10, we can say that's 2 times 5 times x. And if we factor, or you should really say factorise, 15, that would be 3 times 5. And then look carefully here. You can see a common factor in both. And if you take that out as a common factor and put a bracket, and then you've got 2 times x left, yeah, which is 2x, minus, well, 3 was left here. Okay, so let's go through that process again. You take the 10x and you look at the negative 15. You factorise the numbers here. The 10 is 2 times 5 times x, and you do the same to the 15, which is 3 times 5. You then look at the common factor, which is 5, and then whatever's left here, the 2x and the minus 3, is what you put in the bracket. And then you can always check and see if it works by just doing the opposite of factorising, which is expanding. And you can just write 5 here, 2x minus 3, multiply them out, and you'd get 10x minus 15, and then you would know that you were correct. So part C, solve 5p equals 3p plus 8. Well, the idea is to have p on one of the sides of the equation, and then what's left on the other side will be what we need to the value of p. That's the simplest way of looking at it, and you must do the same thing to both sides because this is a balance, i.e. this side balances completely with this side. So one thing I would do is I would take 3p from here, and that would have the effect of getting rid of p on the right hand side. When I say right hand side, I mean the right hand side of the equation, this being the left hand side. And then I must take 3p from this side as well, because I must do the same to keep the balance. So I'd end up with 2p equals 8. So what that means is, it means 2 times something is 8. And you could probably think of that in your head and work out the answer and just simply write down p is 4 and you'd be correct. If you wanted to just do the same thing to both sides to get the answer, then because you had 2 times p, you do the opposite to both sides and divide by 2, and then you would just get p equals 8 divided by 2, and you could write that as a fraction and get 4 marks if you wanted, or you could just do 8 divided by 2 and get 4. So p is 4. Question 18. It says there are 64 cards in a pack. Each card is either red or black. And it says the ratio of the number of red cards to black cards, so red to black, is 1 to 1. That means for every 1 red card there's 1 black card, so there's the same number of each type. It says 8 red cards are removed from the pack. And it says find the ratio of the number of red cards now in the pack to the number of black cards. That's quite a difficult question if you're not used to ratio, but here's how I would explain it. If there are 64 cards to start with, you could say for every 32 red there's 32 black, because you know you can divide both sides of this ratio by 32 and get back to 1 to 1. Now we know that 8 red cards were removed from the pack, so if we take 8 off here, that means that we've got 24 red for 32 black. And all we need to do is just cancel that ratio down into its simplest form. So we can halve both sides and get 12 to 16, halve again and get 6 to 8, and then finally halve again and get 3 to 4. And that's all that's really involved in that question. So it's a bit of common sense, but it is trying to read the question carefully, especially seeing where it says simplest form. Question 19. Here are a 4-sided spinner and a 5-sided spinner, and it says the spinners are fair. which means they've got equally likely chance of landing on each of their numbers, i.e. not biased. Jeff is going to spin each spinner once. Each spinner will land on a number, and Jeff will get his score by adding these two numbers together. Complete the possibility space diagram for each possible score. Well, that's okay then, because we just add these numbers together. So we can get 2 and 2 is 4, 3 and 2 is 5, and so on. And then we can get on with the question. So that's 1 mark, a nice easy mark there. And then it says, Jeff spins each spinner once. Find the probability that Jeff gets a score of 3. So let's look at how many 3s there are as totals in here in the table. Well, it looks as though there are 2 3s out of a total possibility space. So we've got 1, 2, 3, 4 by 1, 2, 3, 4, 5 numbers. So 4 by 5, that's 20 outcomes. So we've got 2 out of 20 outcomes will score 3. And we can cancel that down. We don't need to, but 1 out of 10 would be fine as well. The next part of the question says, work out the probability of having a score of 5 or more. So let's look at the grid. And then ones of 5 or more. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 choices here out of a possible space of 20. So you could leave that as your answer, or you could cancel it down to an equivalent fraction of 7 out of 10. So don't forget, you could have written 0.7 or 70%, but fractions are probably the best way of writing them. Question 20. It says water flows through a pipe at a rate of 20 gallons per 1 minute. And it says what 1 gallon is. So if 1 gallon is 4.55 litres, then it wants to change 20 gallons per minute into litres per second. Okay? Well, first of all, there's going to be an intermediate step here. So 20 gallons, we can do 20 times 4.55, and you can use your calculator for that or not, it's up to you. So 20 times 4.55, that would be 91 gallons in 1 minute. So 91 litres, sorry, in 1 minute. Now, we're nearly there because we've got the litres part of the dimensions. When I say dimensions, it just tells you the units that you're using, so litres per second. And we've got 1 minute, and we all know what that is. It's 60 seconds. And therefore, we've got 91 over 60 litres per second. And when I say litres per second, the per part is like having percentage, which is out of 100. So litres per second, you write L and then per, which means divide by seconds. Just like if you had 80%, it would be 80 divided by 100. Okay, so don't forget what this word actually means and where it comes from. So all we've got to do is 91 divided by 60, and that gives us 1.516 recurring litres per second, and it wants it to 3 significant figures here. So first, second, third, and the 6 would change the 1 to a 2, so we've got 1.52 litres per second. Or you could just write it in plain English like so. But I would write in here 3SF. Always tell the examiner what you've rounded to. Okay, so that's question 20. Question 21. Find the highest common factor of 32, 48 and 72. Well, one nice way of doing this is to just find the prime factor decomposition of each of those numbers. So we look at numbers which are prime. So the nicest one here, as they're all even, is 2. So that's 2 times 16. But 16 is 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. So we've got 2 times 2 times 2 times 2 times 2. And that's how we can write 32. 48, well, that's 2 times 24. And 24 is 2 times 12. And 12 is 2 times 6. And 6 is 2 times 3. So we end up with 2 times 2 times 2 times 2 times 3. And that's for 48. For 72, that's 2 times 36. 36 is 2 times 18, which is 2 times 9, which is 3 times 3. So we end up with 2 times 2 times 2 times 3 times 3. So let's have a look at what they have in common. So they have one multiple of 2 here, another power of 2 here, so that's 4, and another one, so that's 8. Now, they don't have anything else all in common here. So for me, what I would say is, as we've circled 2 times 2, which is 4, times 2 is 8 in each of them, and I can't go any higher because I don't have anything else completely in common, then I would say 8 is the highest common factor of those 3 numbers. Question 22. It says, describe the single transformation that maps shape A onto shape B. Well, let's pick a corner on A and a corresponding one on B, and let's see what we can do. It seems to be going along 1, 2, 3, 4 on the X, and down 1, 2, 3 on the Y. So we can write that as a column vector here, 4 minus 3. And how has this point here moved? Well, it has translated 4 units to the right on the X and down 3 units parallel to the Y-axis. So the word we're trying to use here is translation. So we've got a translation of 4, negative 3, which we can write as a column vector. And that should work for any point. So let's have a look. 1, 2, 3, 4, and then 1, 2, 3 down. Okay, say for this one, 1, 2, 3, 4, and then 1, 2, 3 down. Okay, so this is what we'd write for the answer. Question 23. The time series graph shows information about the percentages of people in a village that use the village shop for the years between 1980 and 2010. And time series just means how some data changes over time. Okay, and that's all it means. It's nice and simple. And we have to describe the trend in the percentage of the people in the village who use the shop for this period. Well, hopefully you can see that it's a downward trend, and I would say something like this. The percentage of people who use the shop decreases, and that's a perfectly fine answer. Well, the next part is something that I haven't really done before, not in a GCSE paper, not for a very long time, if at all. I know it's simple, it's kind of like a correlation graph, but I've not seen it in this kind of context of time series. It says use the graph to predict the percentage of the people in the village likely to use the shop in the year 2020. So I think what I would do here is I would draw a trend line. I hope that's going to be right. If not, I'm sure people are going to tell me. So I'll choose this colour, orange, and let's get that line in. And let's put it where it covers most of the points here. So I think that will be my trend line there. So it's like a correlation graph where you've got to draw the line of best fit. So what we need to do is draw a dotted line up here and then read across. You use a ruler, of course. And we've got 10, 11, 12, 13, 14, 15, 16, 17 and so on. So I would say 13 would be my answer there. So I would say 13% C trend line. Okay, and I'm sure that you'd get scope for having maybe 14, 15 or 16 or something like that, because if you were to change your line here and have it something like, if I can change it, you might have something like that, for example, or if I can get this right without making a complete mess of it, you might have had something like so, for example, and if you did, then that would just give you 14, okay, as your estimate. So it's not really strict, like you have to nail it on the head and get 13 or you're wrong. You'll have some leeway, okay, so that's that part done. The next part of the question says, is your prediction reliable? Explain your answer. Well, looking here, it seemed to go up to 2010, and 2020 is a good 10 years later. So I would say probably not reliable. In fact, I'll be very definite here, not reliable. And I would say no, because 2020 is way beyond the time period covered by the given data, i.e. it's quite a big jump, okay, from here to here. So that's what I would say. So I'm going to write that down, and hopefully that's going to be all the marks here. So let me write that first. So no, because 2020 is way beyond the time period covered by the data, and you might not need to mention this word here and just cut that out. Okay, so let's have a look at the next question. Question 24. Part A says expand and simplify this expression here. So we have 3 lots of y minus 2, and we have 5 lots of 2y plus 1. So first of all, we have 3 lots of y, which is 3y, and then 3 lots of minus 2, which is negative 6. And we have 5 lots of 2y, which is 10y, and 5 lots of positive 1, which is 5. So that's the expanding part done. Now we're going to simplify and just put things that have like terms. When I say like terms, things that are similar. So for example, this is 3 lots of y, and this is 10 lots of y. So why would you just say 3y add 10y when you can easily say 13y? And then we have negative 6 add 5, which is the same as 5 take away 6. And 5 take away 6 is negative 1. So that's that one done. 13y take away 1. One way you could have done this is just by looking at this. You could have seen 3y and 10y make 13y, and then you could have seen 3 times, I'll do a different colour here, 3 times minus 2, which is minus 6, and then 5 times 1 is 5, and then collected those together and had minus 6 add 5, and you would have still got negative 1. Simplify now. We've got 5 times u squared times w to the power 4 times 7 times u times w to the power 3. So how many powers of u do we have? Well, there's a power of 1 here, and there's a power of 2 here. So in terms of u, we have 3 powers of u. How many powers of w do we have? Well, 4 and 3 more. So we have w to the 7, and then we just have 5 times 7 here, which is 35. So that's the same as saying 35 u cubed w to the 7. Now, you would probably write these a little closer together, because because you wouldn't want the examiner to think that we'd missed out a sign here or something which was wrong. So I probably wouldn't write it like that. I'd write it like this. However, you could write the answer like this: 35w to the 7, u to the 3. And the reason is because it's a timesing relationship, it doesn't matter which order you write these in. The only thing you should really do in maths is always write the number part first. So you wouldn't write u cubed 35w7. You wouldn't write w7 u cubed 35. Those would definitely be wrong. But this would be fine, and so would that. Question 25. The diagram shows a regular octagon and a regular hexagon. So the fact that they're regular means that the sides are the same length. One's an 8-sided shape, the octagon, and the other is a 6-sided shape, a hexagon. So I'm going to start with the octagon here. I'm going to look at a slice of it, and then I'm going to do the same for the hexagon. And I'm just going to enlarge this here. Now, on your calculator, you should be able to work out that the whole turn here is 360. So one slice will be 360 divided by 8, which you can work out on your calculator, and that should be 45 degrees here. If you do the same for the hexagon, you'll be doing 360, i.e. all around the point. So that's 360 divided by 6, and that would be 60 degrees here. Now, what you can then work out is that in each of these triangles here, these are isosceles, and so is this one. So this one is easy, they're all going to be 60, it's going to be equilateral. And in this one, as I've got 45 used up already, then the other two are going to be worth 135 between them, because these angles here plus 45 must make 180. So they're going to be 67.5 each, and you can use your calculator to help you work that out if you need it. So let's put those in here. So we'll have 67.5 for each of them. Now, the nice thing is that if we did this again, then we'd have another 67.5 here, and then if we did this one here, we'd have another 60 here. And the nice thing is that if we go around, and we'll use another colour here, if I started here and went all the way around back to the start again, that would be 360, wouldn't it? So on your calculator you can add up all of these four, so that I think I'd make that in my head as 240 plus 15, which is 255, and then I know what's left must be 105 degrees for x. Okay, so that would be my answer. Of course, when you're doing this in the exam, you'd use words like isosceles, but then if you draw the diagram really clearly and you use words like angles around a point equal 360, use a bit of shorthand there, then you should be okay. Your diagram, if done accurately, with your things to show isosceles, for example, and a few calculations, then your 105 as your answer will be clearly understood. Question 26. It shows a Venn diagram, and first of all it's asking you for A union B. So it's what A and B have together as a whole set. So we've got these numbers, and I'll put them in order. We've got a 10, that's in B, but if we want A and B together, then we've got the 10, we've got the 12 here, that's shared by A and B, so that's actually one of these, A intersect B. But 10, 12, 14, 16, I should have written the 15 here, so I'll just change that to 15, and then we've got the 16, and then finally the 18. So that's like the union of A and B together. However, this now means A intersect B. So that's like what they have as an intersect in terms of where they intersect each other. It's like the overlap between them. Okay? And that's clearly 12 and 18 is the intersection there. Okay? So this is okay to remember because it's like the U for union. This one's a little harder, okay, the intersection. Now it says one of the numbers in the diagram is chosen at random, and it says find the probability that the number is in set A prime. Now for me, it's been a very long time since I did Venn diagrams. I'm not going to say how long, but a long time ago. Now A prime to me, as Venn diagrams, is also new to me. It's new on the syllabus. A prime means everything outside of A. That's everything outside of A. So I'm just going to circle those numbers here. So they are not in A. So it says the probability that the number is not in A, i.e. A prime, well, that would be 1, 2, 3, 4, 5, 6, 7 of those numbers that are outside, out of how many numbers there are altogether, which is 1, 2, 3, and the 7 is 10. So I would say 7 out of 10 probability, or 70%, or 0.7 will be the probability that the number is in set A prime. Question 27. Quite a difficult question. It says, on a farm, the number of cows and the number of sheep. So we have cows to sheep. That's the ratio 6 to 5. And then it says the number of sheep and the number of pigs. So sheep to pigs is 2 to 1. The total number of cows, sheep and pigs on the farm is 189, and it says how many sheep are there on the farm. Well, I think automatically, having not done a question like this before on Edexcel, this is a new type of question, I would think what links both statements, and what links both statements is sheep. So if we can try and get these numbers the same, then we're on a winner. So I think with this ratio, I'm going to double it. So that's the same as 12 to 10, 6 to 5, 12 to 10. And then if I times this one by 5, both sides, I'd have 10 to 5. So now I've got a link between them. So I can say that the ratio of cows to sheep to pigs is 12 here for the cows, 10 links both of them, and pigs 5. Now I can look at this total here. The total number of cows, sheep and pigs on the farm is 189, and then I treat this like a normal ratio problem. I see how many parts it's split up into, so 12 and 10 and 5. Well, that's 27 parts. I have 189 animals altogether. So we can see how many it is per part. And I'll do 189 divided by 27 on my calculator. And that is 7 animals per part. That's 189 divided by 27. And then it says how many sheep are there? Well, there's 10 parts here, and each part is worth 7, so there'd be 70 sheep. So not too bad if you actually try and get one of the parts of the ratios linking both statements together. Question 28. It says the arc ABC, here, ABC, the curved part, is a quarter of a circle with centre 0 and radius 4.8 centimetres. And it says AC here is a chord of the circle. It says work out the area of the shaded segment. And we've got to give our answer to correct to 3 significant figures. So we can use the calculator here. You can use it as we go through the problem. I'll try not to, because I don't like having to depend on the calculator too much. And I know I get complaints from people who say, it's a calculator paper, use a calculator. Well, I argue the opposite, because I'd much rather not be dependent on one and only use it if I have to. But it's a personal choice, it's really up to you. So let's get going on finding the area of the quarter circle. And we know that the area of a circle is pi r squared. So we know that an area of the quarter circle is going to be pi times the radius, in this case 4.8 squared, but we want a quarter of it. Okay, and what I'm going to do is I'm going to use that calculator now. So I'm going to put that in, and I get 4.8 squared times pi, and then I'm going to divide the answer by 4, and my calculator says 144/25 of pi, which I could decimalize later if I want to. So that's the area of all of this part here. So all I wish to do now is just take the area of this triangle away, and I should have this part here that I need. So the area of, and I'll do this in a different colour, the area of the triangle is going to be base times height halved. So you can imagine that this was a square where it's 4.8 by 4.8. So we can go 4.8 times 4.8 halved. And I use my calculator for that. So 4.8 squared, and then divide that by 2. And I get 288/25. That's what my calculator does. It just puts it into a fraction. So what I'm going to do is I'm just going to take the area of the circle, which is 144 pi over 25, and I'm going to take the area of the triangle away. So I end up with a common denominator here, and then the numerator will be 144 pi minus 288. Now, a lot of you will be saying, well, just use the calculator and just get the answer and move on. But you'll miss out on certain techniques here which will serve you well later on. Because if you look at the numerator, 144 is a factor, so we can take out pi and then minus 2 here and divide that by 25 and call it units squared. Now I'm going to use the calculator to work out the answer that the question would like, and that's 3 significant figures. So I'll have 144 brackets pi minus 2 close bracket divide by 25, and I'll get 6.57557365, and I want that to 3 significant figures. That's what the question wants. So it will be 6.58, because this 5 would have an effect on the 7, units squared, and I'm going to write that to 3 SF, and I've just noticed the units is centimetres, so I should write this really. Okay, so that's how I would work out that particular question. Question 29. ABC here, ABC is an isosceles triangle with BA equal to BC. D lies on AC, and it says that ABD is also an isosceles triangle. So ABD is an isosceles triangle with AB equal to AD. So we can also put this on here and this on here. It says angle ABD is 72 degrees, and you've got to show that triangle BCD here is an isosceles triangle. So let's have a look at what we've got. Well, we firstly know that AD and AB are the same length and ABD is isosceles, and so this angle here must be 72 degrees also, because base angles of an isosceles triangle are equal. This would then mean we can find angle A, because we know that 72 and 72 is 144, which leaves 36 left for this angle here. Now, also remember that AB and BC are the same length because triangle ABC is isosceles. So we know this angle is 36 here. We've just shown that. So this angle must be 36 because it's isosceles. So if those two angles here are 36 each, then 36 and 36, that makes 72, which leaves 108 for this top angle here, because angles in a triangle add up to 180. So if there's 108 for the top angle, and we've already got 72, well, that leaves 36 left for this angle here. Now that seems like quite a lot of work, because we've shown that this angle and this angle are the same, so therefore two angles are the same, so it must be isosceles. So we have shown that triangle BDC is isosceles because two of the angles are the same, and this top angle would be 108 here. And we know that also because 72 here and 108 make angles on a straight line, so there was an alternative method there. But all we had to do was show that two of the angles were indeed the same. If three of the angles had been the same, it would have been equilateral, but because two of them are just the same, then it's isosceles. Now, I haven't written down all the explanations here, I've just shown you a way through doing the problem, and you must give your own reasons at each stage, and it's just simple things like angles in a triangle add up to 180, AB equals BC, for example, or angles on a straight line add up to 180. You must write those sentences yourself. But this is just a little overview for you of question 29.